Okay, here's the first one you sent me. It says, with one method of procedure called acceptance sampling, a sample of items is randomly selected without replacement and the entire batch is rejected if there's at least one defective unit. So they manufacture 7,000 CDs and 110 are defective. If I pick 3 at random, what's the probability that the entire batch is rejected? So I'm looking for the probability that 1 is bad, 1 defect, plus the probability of 2 defects, plus the probability of 3 defects. So these are the 3 ways that the batch can be rejected. 1 defect, 2 defects, 3 defects. But that's kind of a painstaking process. What I'm going to do instead is I'm just going to figure out what's the alternative to that. What's the probability of no defects? So that's the complement. It's the opposite. It's the only other possibility. So if I want to find the probability of the green, I'm just going to do 1 minus the probability of the red. So let's figure that out. Probability of no defects. I'm picking 3 CDs. There's 7,000. 110 are defective. So the probability of the first one is not defective is 6,890 out of 7,000. Now I'm going to times. I get a non-defective CD. So now there's 6,889 left out of 6,999 left. I'll do that again, and now there's 6,888 out of 6,998 defective CDs. Or not defective CDs, I'm sorry. So I'll just put that in the calculator. So I'll do the fractions first. This is going to be 6890. I'll do the numerators first, times 6889 times 6888. The denominator is going to be 7,000 times 6999 times 6998. I'll just take this and divide by that. So that's what you got here, but remember, it's the complement. So I'm going to do 1 minus. So I think you're actually very close. So you should really get 0.046, or as a percentage, this is going to be 4.6%. You actually found the probability of the complement. Okay, and the next one, where is it? Let me go back to that. Oh, it didn't copy. Okay. Give me 1 second. All right. So this is the same idea, but it says if we're taking a sample of blood, 5 samples, we will reject if any one of the samples is positive. And they have a chance of being positive at a 0.06% or 0.06 probability. So I want to know, okay, instead of finding probability that one of the samples is bad, we'll say 1 bad, plus the probability that 2 bad, up to the probability of 5 bad, I can just find the complement. I can do 1 minus the probability that none are bad. Now I'll use the same logic in this question here. So it says 1 minus the probability the first one's not bad. Well, if this is the probability for being positive, we want the complement. So this is going to be 0.94 for the first one, 0.94 for the second, 0.94 for the third, all the way up to the fifth. So this is going to be 0.94 to the 5th power. I'll just do that first. 0.94 to the 5th power. Now I'm going to do 1 minus that. So you have 0.26609, or let's see here, 26.6%. And that's it.